Pythagoras was a Greek mathematician and philosopher whose work profoundly shaped geometry and number theory. Born on the island of Samos, Greece around 570 BC, he traveled to Egypt and Babylon studying mathematics and ancient wisdom. Pythagoras is best known for the Pythagorean theorem, which states that in a right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. He founded the Pythagorean school in southern Italy, where mathematics was central to understanding reality. His work in number theory led to the discovery of irrational numbers, and he believed that numbers were the fundamental essence of all things. He died around 495 BC in southern Italy. His theorem remains fundamental to geometry and is taught worldwide, influencing mathematicians from Euclid to modern physicists. Euclid was a Greek mathematician whose work established the foundations of geometry and mathematical reasoning. Born in Alexandria, Egypt around 300 BC, he likely studied at Plato's Academy in Athens. Euclid is best known for his masterwork Elements, a comprehensive compilation of geometric knowledge consisting of 13 books covering plane geometry, solid geometry, and number theory. This work established the axiomatic method, presenting definitions, axioms, and postulates from which all geometric truths could be logically derived. He taught at the Great Library of Alexandria, where he trained students in mathematical reasoning. He died around 260 BC in Alexandria. His Elements remained the primary mathematics textbook for over 2,000 years. Archimedes was a Greek mathematician, engineer, and inventor whose contributions shaped mathematics and physics. Born in Syracuse, Sicily around 287 BC, he studied in Alexandria, Egypt under the successors of Euclid. Archimedes is best known for his work on calculating pi and laying foundations for integral calculus through his method of exhaustion. He made groundbreaking discoveries in hydrostatics, including the principle of buoyancy, now called Archimedes' principle. He developed formulas for calculating areas and volumes of spheres, cylinders, and other geometric shapes. He died in 212 BC during the Roman siege of Syracuse, allegedly killed by a soldier, while absorbed in mathematical diagrams. His methods anticipated calculus by nearly 2 millennia, and his work remains essential to engineering mechanics and mathematical analysis. Brahmagupta was an Indian mathematician and astronomer whose innovations transformed algebra and arithmetic. Born in Bhinmal, India, around 598 CE, he studied traditional Indian mathematics and astronomy. Brahmagupta is best known for his systematic treatment of zero as a number, including rules for arithmetic operations involving zero and negative numbers. His major work, Brahmasfuta Siddhanta, written in 628 CE, presented solutions to quadratic equations and methods for calculating with fractions. He worked as the head of the Astronomical Observatory at Ujjain. He died around 668 CE in India. Brahmagupta's treatment of zero and negative numbers was revolutionary, enabling the development of algebra as we know it, and his work influenced Islamic mathematicians like Al-Khwarizmi. Al-Khwarizmi was a Persian mathematician, astronomer, and scholar whose work gave birth to algebra. Born around 780 in Khwarazm, which is now Uzbekistan, he worked at the House of Wisdom in Baghdad. Al-Khwarizmi is best known for his book on algebra, which introduced systematic methods for solving linear and quadratic equations. The word algebra derives from al-jabr in this title, and his name gave us the word algorithm. He promoted the use of Hindu-Arabic numerals, including zero, which revolutionized calculation methods. He died around 850 in Baghdad. Al-Khwarizmi's work spread throughout the Islamic world and into Europe, fundamentally changing how mathematics was practiced, and his systematic approach made modern mathematics and computer science possible. Fibonacci was an Italian mathematician who introduced the Hindu-Arabic numeral system to Europe. Born as Leonardo Bonacci in Pisa, Italy, around 1170, he traveled with his father to North Africa, where he learned the Hindu-Arabic numeral system. Fibonacci is best known for the Fibonacci sequence, where each number is the sum of the two preceding ones, appearing in his book Liber Abaci, published in 1202. This work demonstrated the superiority of Hindu-Arabic numerals over Roman numerals for calculation. The sequence appears throughout nature in spiral patterns of shells, sunflowers, and galaxies. He died around 1250 in Pisa. The Fibonacci sequence remains one of the most studied mathematical patterns appearing in computer algorithms, art, and natural phenomena worldwide. Pierre de Fermat was a French mathematician who made groundbreaking contributions to number theory. Born in Beaumont-de-Lomagne, France in 1607, he studied law and worked as a lawyer throughout his life. Fermat is best known for his last theorem, which states that no three positive integers can satisfy. He made fundamental contributions to analytic geometry, probability theory, and calculus, corresponding with other mathematicians through letters. He pursued mathematics as a passionate hobby, never publishing his proofs. He died in 1665 in Castres, France. His last theorem remained unproved for over 350 years, finally solved by Andrew Wiles in 1995. Isaac Newton. Born in 1642 in Lincolnshire, England, Newton transformed natural philosophy through his unification of mathematics and physical science. During the plague years of 1665 to 66, while isolated at his family home, the 23-year-old Newton developed the foundations of calculus, formulated laws of motion and gravitation, and conducted experiments in optics. His method of fluxions and fluents provided systematic techniques for differentiation and integration, though priority disputes with Leibniz over calculus's invention created lasting controversy. In 1687, Newton published Philosophiae Naturalis Principia Mathematica, arguably the most influential scientific work ever written. The Principia presented his three laws of motion and the law of universal gravitation, showing that the same force governing falling apples also governs planetary motion. Using geometric methods and calculus, he derived Kepler's laws of planetary motion from gravitational principles and explained tides, precession of equinoxes, and comet trajectories. Newton's mathematical contributions extended beyond calculus. He developed methods for approximating roots of equations, classified cubic curves, and contributed to finite differences and interpolation. His binomial theorem generalized to non-integer exponents, expanding the scope of algebraic manipulation. In optics, Newton's experiments with prisms demonstrated that white light comprises a spectrum of colors. He built the first reflecting telescope, designed to avoid chromatic aberration. His optics explored light's nature and introduced queries about light particles versus waves, stimulating centuries of debate. Newton served as Lucasian Professor at Cambridge, Master of the Royal Mint, and President of the Royal Society. His personality was complex, intensely private, often vindictive toward rivals, yet capable of profound insight. He died in 1727. Having established the mathematical framework for classical physics, Gottfried Wilhelm Leibniz was a German polymath who independently developed calculus and made vast contributions to philosophy. Born on July 1, 1646 in Leipzig, Germany, he studied philosophy and law, becoming proficient in multiple disciplines. Leibniz is best known for developing calculus independently of Newton, introducing the notation we still use today, including the integral sign. He died on November 14, 1716, in Hanover, Germany. Leonhard Euler. Born in Basel, Switzerland in 1707, Euler became the most prolific mathematician in history. He studied under Johann Bernoulli and produced over 800 publications spanning nearly every mathematical field. Euler revolutionized mathematical notation, introducing symbols that became universal standards. E for the natural logarithm base, I for the imaginary unit, f of x for function notation, and sigma for summation. These conventions transformed how mathematics is written and communicated. His work in analysis was foundational. He developed the calculus of variations, solved the Basel problem by proving the sum of reciprocals of perfect squares equals pi squared over 6, and derived the Euler-Mascheroni constant. The Euler identity, e to the power of I pi plus 1 equals 0, elegantly connects 5 fundamental mathematical constants. In topology, Euler solved the 7 bridges of Königsberg problem, effectively founding graph theory. His formula V minus E plus F equals 2 for polyhedra established the field of topology. He made fundamental advances in number theory, proving Fermat's little theorem and studying perfect numbers and prime distributions. Euler transformed mechanics and fluid dynamics through the Euler equations, which describe fluid flow. After becoming completely blind in 1766, he worked until his death in 1783, leaving a legacy that touches virtually every branch of mathematics. Carl Friedrich Gauss. Born in 1777 in Brunswick, Germany, Gauss displayed extraordinary mathematical talent from childhood. At age 3, he corrected his father's arithmetic calculations. By 10, he had discovered the formula for summing arithmetic sequences. His doctoral dissertation in 1799 provided the first rigorous proof of the fundamental theorem of algebra, establishing that every polynomial equation has at least one complex root. In 1801, he published Disquisitiones Arithmeticae, which revolutionized number theory and introduced modular arithmetic. The work established congruence notation and proved the law of quadratic reciprocity. one of number theory's most important results. Gauss made groundbreaking contributions to differential geometry, developing the theory of curved surfaces and introducing Gaussian curvature. Gauss calculated the orbit of the asteroid Ceres using only 3 observations, developing the method of least squares in the process. This statistical technique remains fundamental across scientific disciplines. His contributions to magnetism and electricity, formalized in Gauss's law, bridged mathematics and physics. He worked on non-Euclidean geometry, but never published these results, fearing controversy. After his death in 1855, his private notebooks revealed he had anticipated many later discoveries. Karl Weierstrass was a German mathematician who established rigorous foundations for mathematical analysis. Born on October 31, 1815 in Ostenfelde, Prussia, he initially studied law before pursuing mathematics through self-study. Weierstrass is best known for his epsilon-delta definitions that made calculus completely rigorous and his discovery of continuous, nowhere differentiable functions. He developed the theory of uniform convergence and provided rigorous foundations for complex analysis. He died on February 19, 1897, in Berlin, Germany. Evariste Galois. Born in 1811 near Paris, Galois compressed revolutionary mathematical discoveries into a tragically brief life. He developed group theory and Galois theory. Galois introduced the concept of groups to study permutations of polynomial roots. He showed that a polynomial equation is solvable by radicals if and only if its Galois group is solvable in a specific group-theoretic sense. This connected abstract algebra to classical equation theory, revealing deep structural relationships. The general quintic equation has no radical formula because its symmetry group, S5, is not solvable. This explained why centuries of attempts to find such formulas had failed. Galois theory became fundamental to modern algebra, influencing field theory, algebraic number theory, and algebraic geometry. The concept of groups extended far beyond Galois' original application, becoming central to mathematics and physics. Galois' life was turbulent. He failed entrance exams to École Polytechnique, was expelled from École Normale for political activities, and was imprisoned for Republican activism. The French Academy twice rejected his mathematical work, failing to recognize its importance. On May 30, 1832, the 20-year-old Galois fought a duel, reportedly over a woman. The night before, knowing he might die, he wrote feverish letters explaining his mathematical discoveries, noting, "I have not time," in margins. He died from his wounds the next day. Galois' manuscripts were published in 1846 by Louville, 14 years posthumously. Mathematicians gradually realized the depth of his contributions. His ability to see fundamental mathematical structures that eluded contemporary mathematicians, despite minimal formal training, and dying at 20, marks him as one of history's most remarkable mathematical minds. Bernhard Riemann. Born in 1826 in the Kingdom of Hanover, Riemann revolutionized mathematics despite a short career cut short by tuberculosis. He studied under Gauss at Göttingen and produced work of exceptional depth. His 1854 habilitation lecture, On the Hypotheses Which Lie at the Foundations of Geometry, introduced Riemannian geometry. This framework generalized Euclidean geometry to curved spaces of arbitrary dimension, introducing the Riemann curvature tensor. 60 years later, Einstein used Riemannian geometry as the mathematical foundation for general relativity, describing gravity as space-time curvature. In complex analysis, Riemann developed the theory of Riemann surfaces, providing geometric understanding of multi-valued complex functions. He introduced the Riemann mapping theorem and studied conformal mappings, establishing complex analysis as a rigorous discipline. His 1859 paper, On the Number of Primes Less Than a Given Magnitude, introduced the Riemann zeta function and proposed the Riemann hypothesis. All non-trivial zeros of the zeta function have real part 1/2. This conjecture remains unproven and is considered mathematics' most important unsolved problem, with profound implications for prime number distribution. Riemann contributed to mathematical physics through his work on partial differential equations, heat conduction, and shock waves. The Riemann integral provided a rigorous foundation for integration theory. Despite dying at 39 in 1866, Riemann's ideas fundamentally reshaped geometry, analysis, and number theory, creating mathematical structures that continue driving research. Georg Cantor was a German mathematician who founded set theory and revolutionized the understanding of infinity. Born on March 3, 1845 in St. Petersburg, Russia, he studied at the University of Berlin under Weierstrass. He died on January 6, 1918, in Halle, Germany. David Hilbert. Born in 1862 in Königsberg, Prussia, Hilbert dominated early 20th century mathematics through technical achievements and visionary problem setting. At Göttingen, he created an intellectual center that attracted the era's finest mathematical minds. His work on invariant theory in the 1890s revolutionized the field by proving existence theorems without explicit construction, introducing a new level of abstraction. His Grundlagen der Geometrie, Foundations of Geometry, in 1899 rigorously axiomatized Euclidean geometry, clarifying logical dependencies between geometric axioms. At the 1900 International Congress of Mathematicians in Paris, Hilbert presented 23 unsolved problems that guided mathematical research throughout the century. These problems spanned number theory, algebra, analysis, and mathematical physics. Solving even one earned lasting recognition. The Hilbert problems demonstrated his insight into which questions would prove most fruitful. Hilbert introduced the concept of Hilbert spaces, infinite-dimensional generalizations of Euclidean space, that became central to functional analysis and quantum mechanics. His work provided the mathematical framework for Heisenberg's uncertainty principle and Schrödinger's wave equation. In mathematical logic, Hilbert championed formalism, the view that mathematics consists of manipulating symbols according to specified rules. His program aimed to prove consistency of mathematics using finitary methods, though Gödel's incompleteness theorems showed limitations of this program. Hilbert's approach profoundly influenced logic and foundations. He contributed to integral equations, calculus of variations, and relativity theory. He died in 1943, having shaped mathematics' direction through technical mastery and strategic vision. Emmy Noether was a German mathematician who revolutionized abstract algebra and theoretical physics. Born on March 23, 1882 in Erlangen, Bavaria, she initially studied languages, but switched to mathematics, facing discrimination as women were not officially allowed to enroll. Noether is best known for Noether's theorem, which links symmetries in physics to conservation law, revolutionizing theoretical physics. She made groundbreaking contributions to abstract algebra developing ring theory. Despite her brilliance, she struggled to obtain paid academic positions due to gender discrimination. She died on April 14, 1935, in Bryn Mawr, Pennsylvania, after fleeing Nazi Germany. Noether's theorem remains central to modern physics, and her contributions to abstract algebra fundamentally shaped 20th century mathematics. Gödel is best known for his incompleteness theorems published in 1931, which prove that in any consistent formal system containing arithmetic, there are true statements that cannot be proved within that system. These revolutionary results shattered hopes of completely formalizing mathematics and had profound implications for philosophy and computer science. He worked at the Institute for Advanced Study in Princeton. He died on January 14, 1978, in Princeton, New Jersey. Gödel's incompleteness theorems rank among the most important results in mathematical logic, fundamentally changing our understanding of mathematics. Alexander Grothendieck was a stateless mathematician who revolutionized algebraic geometry and created entirely new mathematical frameworks. Born on March 28, 1928 in Berlin, Germany, he survived internment camps and studied mathematics at the University of Montpellier. Grothendieck is best known for developing the theory of schemes, which generalized algebraic varieties and revolutionized algebraic geometry. He introduced category theory and functorial methods as central tools in mathematics. He received the Fields Medal in 1966 and worked at the Institut des Hautes Études Scientifiques. He died on November 13, 2014, in Saint-Girons, France. Grothendieck's revolutionary reimagining of algebraic geometry created the foundation for modern number theory, and his categorical approach influenced virtually all areas of pure mathematics. Thank you very much for watching this video.